Okay, let's jump right in. Today, I think we have a completely dead Apple floppy drive of the 800K variety. Here we can see it has a couple of notes, quite scary ones in fact. Do not connect to computer, troubleshoot, dead, blows computer's power supply. Well, that's not great, so I think the first thing we'll have to do is open up this unit, do some investigations. I have the pinout here on another screen, so we're going to run through some of the connections. First thoughts are that potentially it's shorted to ground, or potentially it's sending one of the power inputs out through one of the power or data lines. So before we connect it to a computer, I think we'll heed the warnings that this particular drive came with, and well, no other great place to start but just to open it right up. Alright, let's get this screen cellophane off of here. It's like a wrapping material. Get rid of that. Do not connect to computer. Troubleshoot. Dead. Blows computer's power supply. I think we'll leave that on there until we actually fix the problem. A little bit of minor case damage. There's a couple of cracks here in the plastic. Front actually looks pretty good. Small crack here. I don't know how well that's showing up on the camera. Small crack here. Mostly I think the case would clean up, despite for those few little cracks. It actually does have all of its feet. Sometimes these get stuck or they get really sticky. These aren't so bad. The cable's pretty dirty, but otherwise in pretty good shape. All right. Let's get right into this thing and see what's inside. Case should just come right apart. Uh-oh. That doesn't bode well. That looks like the cover for one of the heads. So there's definitely some interesting stuff going on. So not terribly rusty. I was expecting this to be a little bit more rusty on the inside, so it actually seems like it was kept in a fairly decent environment. So move this out of the way. Okay. Next we'll remove this plate. It's being held on by two more screws. And I thought this was magnetic. Probably good that it isn't. And the drive should just lift up and out. And there's the drive. And its metal bracket, of course. Apple known for over-engineering products of this time, or any time really. Yeah, upon first inspection, I don't see any particular damage. Okay. Let's get this the rest of the way out. Connector should just pull right off. There we go. Typical Apple floppy connector. And hopefully this drive will slide out of its cage. Or not. There we go. Come on. there's a sticker that it's getting caught on. Okay, all right. Look at that giant metal bracket. And yeah, as suspected, that is the cover off of the top head. Thankfully it doesn't require that piece, but a little bit disturbing that it's not there. So I guess let's see. It's not that bad. You see these a lot more gummed up. Let's see if I can remember how. There is a way to test this, but I forget precisely how that works. Okay, we'll come back to that later. Overall, in very good shape. Doesn't appear to be anything necessarily blown on the circuit board. Okay. So let's take a look at the cable. The wires seem okay. Let's plug this back in and we'll run through some of the pinouts. Now, if you're ever unsure in looking at a pinout, especially of these D-sub style connectors, a great place to look is to reference some of the grounds. So the pinout will know some of these pins are the grounds. Let's check out what we believe to be pin 1. Okay. Huh. That's a little strange, unless they're not connected to the shield. None of these are connected to ground. Alright, that's very strange. So what we'll do is we'll pick apart on the chassis of this floppy drive and just kind of stick this pin in somewhere. Find a good spot for that. It's just on the side. Like one of those mounting points. Let's see if we get any. There we go. Okay. So based off of the pinout, we know that pins 1, 2, and 3 should be ground. That's good news. Let's check if any of these other ones are shorted to ground. I don't believe they should be. Unless there's a capacitor pulling it up. Okay. Looks like pin 4 is also a ground. But if we test the rest of these, okay. Nothing else is shorted to ground. So the next thing will be is to check if between ground, well, I suppose we just checked that, didn't we? So according to the pinout, pin 6, this is now not the orientation, so I guess it's reversed. So take a look here at the connector. So we have pins 1, 2, 3, and 4. Ground. We would expect pin 6. 1, 2, 3, 4, 5, 6. So we don't have any short on the 5-volt rail. And these are positive 12. These are all connected together. So pins 7 and 8 both receive 12 volt, positive 12 volt. We are getting some resistance on the 12 volt, about 50 ohms, which seems a little bit high. So possible we have a short on the 12 volt rail, although not a dead short, otherwise the beep would be. So 1, 2, 3, 4, 5, 6. This is our positive 5 volts. Pins 7 and 8 both have about 50 ohms of resistance. So that's interesting. None of the other pins seem to have any meaningful resistance. Okay. So let's check out the floppy drive itself. Hopefully, pins are actually numbered here on the bottom of the floppy drive. So if we refer back to our pinout, we can re-verify that we have ground on pins 1, 2. This is a bit confusing. Okay, because it's numbered. So we would expect pins 1, 3, and 5 on the internal connector. Will be ground. And then 12 volts, which is present on pins 13, 15, and 17. So counting from this side, so 17. Yep. There we go. We're still getting that 50 ohms of resistance. And these are all connected together. So pins 13, 15, and 17 all appear to have about 50 ohms of resistance. Now, what we'll do, so what we'll actually do here is take a drive that we know works and compare it against. So this should be an identical drive. So you can see the circuit boards are the same. Top layout looks identical. So let's stack this up against a drive that we know works. So first we'll start off with these same grounds. So we'll test pins 1, 2, and 3. So 1, 2, and 3, all ground. And we're going to check pins 13. And hey, look at that. No resistance against the 12 volt rail. So if we go back over to this drive, again, 1, 2, and 3, all ground. And we check pin 13, 15, and 17, and sure enough, that is a short. And just double checking it against the good drive again. So 13, 15, and 17, no resistance. Okay, so that has to be the dreaded kills computer power supply right there. So I guess we have to find on this drive where any potential tantalum capacitors are, being that those are the variety that tend to fail short, although not a dead short. So let's see if we can figure out where some of these go. So let's start here. So we'll take a look at one of these pins, pin 15. See that the little trace, I don't know how well that's coming up on the camera, but there's a little trace It's right down here. And this is a capacitor right here, C4. So if we measure the resistance, this is about exactly what we were getting, is 49 and change. But if I move back to this connector, it's a little bit higher, 49.48.5. Well, actually that's lower, 48.67. And if we check directly across this capacitor, 48.5. So that's hard to say. We will have to look all over this board. Fortunately, what we can do is if we put one of our test probes back here on the connector, see that is connected, and we can check all of these capacitors, see if we can identify ones that are on the 12-volt rail. So again, we'll put our probe on one of these pins, confirm that we're on 12 volt. So it must be one of these capacitors. Or that very first one. God, I hope it's not under this shield. Okay. I don't think we found any other capacitors on the 12-volt rail. So, could this be our short? Could be. Okay. So, be fairly quick. It could just be this one little capacitor right here at the bottom of the board. I hope that's coming up. But I think the focus is locked. There we go. So this capacitor right here is the only one I can find that's across the 12 volt and ground. So let's give that a shot. What we'll do is just apply a little bit of solder on either side of this pin here, this capacitor. Capacitor does not want to budge. Some fresh solder on this tip here. This thing does not want to budge. that's interesting. Stuck to my little tip here. So that's our. But let's check our voltmeter. Let's see if we still have a short. Wow. Yep, same values, so that was not the problem, this little capacitor here. See, this thing has resistance well into the megohms. So I guess we should mount that back, although I should probably clean that up a little bit. Take a small piece of paper towel here, a little bit of IPA, isopropanol. See if we can't clean that up. Let's see what's going on. Get our capacitor back on the board here. This was not our culprit. Surface mount stuff can be a real pain. Get a little bit of solder on our tip. And that's enough to stick it down. Okay. Not the most beautiful soldering job, but we have restored the capacitor. It's on there. So that's worrisome. I'm not really sure. I guess we'll have to look elsewhere on the drive. See what we can see. So I think the easiest thing to do will be to beep this out. So if we tag one of our 12-volt pins, there we go. Let's see if this runs to any of these chips. Expect it to be part of the motor drive. 5 volts being used for logic. Chips. Well, that's surprising. Okay. Looks like this pin travels through here. Doesn't seem right. It says Q7, so a transistor. That side is completely shorted. Maybe that shorted transistor right here. Or is something where this wire goes. Okay, so let's check that out on this good drive. So again, we'll hook up to one of these 12-volt pins, trace it down. Okay. Huh, not quite identical. So here, there's a different, this is a little bit different, definitely a different revision. Very, very similar, not quite the same. You can at least trace that down to the connectors. So if we start over here on our 12 volt, there we go. See, that comes in, it stops here. I wonder, okay, that looks like either a bridge or a resistor. It continues along. And there is no short on this pin of this transistor. And this pin of this connector, but not the other side. Okay. So hopefully this is making it through, but this guy right here seems to be shorted here. Okay. So, and it is not shorted on the other drive. So let's take a look at where this connector goes. This one goes to the eject mechanism. So you would not expect the eject mechanism to be shorting the entire drive. We can find out if that's the case. If we just remove this connector right here, it should pop off. There we go. Yep, that goes to the eject mechanism. So if we check this now, again, this is the pin we know, and it is no longer shorted. Okay. So I think the first thing to do is going to be removing this eject mechanism, which is actually really, really easy. It's only held down by 2 screws. So we'll remove this one here. And this one here. Should just come right out. And there's our eject mechanism. Take a vote down below whether this one has the infamous gear. It is almost certain that it does. Yet to encounter a single one of these drives where that gear was good. They're all just crumble. Just taking a look at this mechanism here, there is a switch. These wires all make it up to the board. Compare that to our mechanism over here. So the switch is open currently on this board. So before we open that, it's best to try to understand this circuit a little bit. So we have the switch, and we have a number of wires. Let's get this a little bit loose, sort of see where these go. So, looks like the brown wire connects to the red wire of the motor, and the red wire to the black wire of the motor, which is a little bit strange. Of course, we have our switch. Looks like one side of the switch is not connected. So currently, let's take a look at this switch. Unfortunately, that's going to be a little tricky to test. Well, that is interesting. However, let's see if just simply disconnecting that has removed that short on the 12-volt rail. So we'll compare that to our ground. And hey, look at that. There's no longer any resistance. So that was enough. That one switch was enough to add 50 ohms on the 12-volt rail. But I have to wonder if that's our problem. And there it is, folks. That is one cracked gear. So let me remove this gear here. We'll just use the tweezers to pull that gear up. And there are bits of the old gear all over. Little teeth broken off. This gear is quite stripped. Let's see if we can get this out of here without it crumbling. So there's our gear. Right here. So typically you can just, wow. It just completely crumbles. There is nothing structurally left of that gear right there. That is gone. Right. So with that free, we can actually move this mechanism. As you can see, this rotates, pushes the switch to let it know that the motor is in position. So with that, should be able to replace that gear. Here we go. I have a whole bag. These replacement Macintosh floppy drive gears. You can find these on eBay, 3D printed. I believe I got these directly from Shapeways. It was much cheaper. Full set of 12. I believe the most expensive part was the shipping. I will link these in the description. But as you can see, I've used a number of these already. And they're actually really nice quality. Printed with an SLA printer, not FDM. So you have a much finer resolution. And they appear to be quite strong. I've replaced these in a number of drives and have not seen one break yet. So first thing we'll do is go ahead and install that back where that original gear was. As you can see, it fits perfectly into place. And we will reinstall this gear right on top. And that's it. If you have one of these drives with a broken eject system, this is most of the time the problem. So with all of that, just clean that up a little bit. Some fresh IPA. Clean this plate up a little bit. We'll go ahead and get that back on the eject mechanism. Eject mechanism. I do wish the screwdriver was magnetic. And a good tip for screwing into plastic is always run the screwdriver backwards for a couple of turns until you hear that little click. That's how you know you're right on the original thread. You don't want to rethread the plastic, otherwise this older plastic is prone to cracking. So just do the same thing on this one. I'll go ahead and tighten all those down. Should be repaired eject mechanism. Although we're still not really sure if that's the actual problem. I think about the only way to find out may be to hook this up to a Macintosh. But before we do that, I do want to run a couple of other checks here. So we know the pinout of this connector. I think one thing that would be prudent is to check that we don't have any leakage from ground or one of the other voltage rails to one of the data lines. That would be unfortunate if not only we blew the power supply but also damaged the actual motherboard. So, I think the easiest thing would would just be to check all of these without looking at the pinout. See if we have any resistance across them. Momentary beep can be normal, charging up capacitors. To any of the other pins on this connector. Okay. Well, I think we have to hook this up to the Macintosh, so let's get that out. So, before we jump in, this is actually a logic board here that I've installed a number of ZIF sockets on. I've even labeled them as to what they are. Kind of have them for all of the major custom chips. So we have a number of PAL and GAL chips. These are programmable logic chips that replace a whole number of 74 series logic chips and can often reduce the chips down from dozens to just a few. So the Macintosh uses a number of these to reduce the parts count of the motherboard a little bit, and I suspect to make it a little bit more difficult to copy, as of course you can't just directly read the code or the mask that are on these particular PAL chips. So unless you have an exact replacement or you have the original mapping, you can't make a new one. And of course, the only other real custom chip is this IWM, which is an integrated WAS machine. This is our floppy disk controller. It can support 2 drives. So here we have the internal floppy port, on the rear external floppy port. Done a couple of other modifications to this board. Instead of the original ROMs, I have the ROMinator installed, which takes that original 512 or 128K of maximum system ROM, brings that all the way up to a full megabyte, I believe. So this contains not only the original system ROMs, but also a copy of System 6.08, which it can boot directly from the ROM. And with that is a small modification that routes some additional address lines from the processor. Instead of just soldering directly to the CPU, I've actually installed, you can kind of see it from this view, there are 2 sockets. So there is a socket installed into the logic board itself, and then a second socket stacked on top, and that's where I've soldered these additional address lines. And then of course the CPU popped in right on top. Nice ceramic 68,000 CPU here. Next thing is, and this is going to make testing this logic board and then this floppy drive tremendously easier, is a slightly extended power cable. And of course this carries the necessary voltages for the logic board. It also carries sound, which goes to the analog board and also the video signals. So this will make it a lot easier. The original one, which I'll disconnect over here. See how short that is. So it's almost twice as long. That's going to make using this outside of the case a lot easier. One tricky thing that Apple has done here is there's actually what I believe is a fuse underneath this ferrite core, and I've replicated that underneath mine. So that's a little bit of trickiness. Apple likes to hide things in the places you wouldn't exactly expect. So And I believe instead of trying to match the original Apple wire colors, I believe these are more appropriate to ATX style, where 5 volts will typically be red, 12 volts typically will be yellow. And if this is 3.3, actually I believe this is the battery voltage, which is 4.5, so I think I used an orange wire there, which is the ATX 3.3. So here we will just connect to, and the pinout for both sides of this is the same. So if the cable ever did get swapped around, it's not the end of the world, but typically you see the ferrite core closest to the logic board. So there, we'll get one end of that connected to the logic board. We'll connect the other end to our analog power supply. Now, of course, the normal caveats apply here. If you don't know what you're doing inside of a high voltage power supply, do not open these computers, do not poke around. And it's even especially more important because we have CRT here, and these are energized at thousands of volts. I believe these are energized around 7,000. Could be wrong, correct me in the comments. And that is realistically it. So, scooch this over a little bit. Better view of the camera here. So here you can see nice long cable hooked up to the analog board. And let's go ahead and get some power. And we'll flip this up. And I don't know if I'll be able to get the actual CRT in view, but this should give us a pretty good view of what's going on. So, first things first, without anything else connected, I think we'll power this up and see if it goes ahead and boots. One of the nice things about the Rominator is that even without any disk drive or hard drive, this computer should fully boot up to the desktop and allow us to run some initial diagnostics. So let's go ahead and give that power switch a flip. There you go, we got the chime. CRT should be warming up. There we go. Get a nice message for press and hold. So we are actually gonna need the keyboard for this. Okay. Let's go ahead and power this down. I forgot whether or not you needed the keyboard for this. I thought it was just the mouse and then it would automatically try to boot into the Rominator, and maybe a configuration option. I'm sure you'd have to reflash the Rominator there. But let's go ahead and get our keyboard connected. Of course, it uses these telephone-like plugs. Do not use an original telephone cord. It is a different pinout. It's not quite the same. Let's see. We can get this mostly in view. All right. Let's give that a go again. Get the nice chime. That is a different chime. They've modified the chime a little bit there in the Rominator. Press and hold R. Welcome to Macintosh. So that's fantastic. You can see how quickly that boots up. It's almost instantaneous, of course, because it's right there on the bus. It's not having to talk to the IWM. It's not having to wait for disk access. This is immediate access. It should be as fast or faster, actually, than trying to read contents from RAM. All right, so here we have the Macintosh booting up, so that is good news. So let's take it to the next level and go ahead and get our disk drive connected. And this is going to be a bit of a moment of truth because we don't actually know if this disk drive is okay. I have this little bit long floppy cable here. So one end into the disk drive, and the other end into the logic board. I have not tested this, so let's see how this goes. Let me know in the comments if you think this is going to work. Here we go. 5, 4, 3, 2, 1. We had some activity and it did not blow the computer's power supply, so I'm not sure what that note means. Okay, the motor did spin. There's obviously some piece of this that is seized up. But let's go for broke. Let's see if we can get cleaning Floppy. Let's put a little bit of IPA on this, just a touch. Some IPA on our cleaning disc here. Let's pop this in. Oh, that sounds unhappy. That sounds very unhappy. Let's see. If we attempt to put in one of our discs here, OS 608 on it. Oof. Oh my god, it's booting. Oh my god, it's booting. Wow. Look at that. That is a working floppy drive. So that is rather surprising. I am very surprised to see that this drive actually just works. And hey, it's actually staying up now. It must have been caught. Oh, that is not good. Okay. So there is definitely something going on with the mechanics of this drive. Probably a good oil will do this thing wonders. But let's try this. Move this out of the way. Power this down. Let's go ahead and connect the drive over its original cable. Maybe that's where our fault is. Before we connect this to the actual drive, let's try plugging this in to the back of the Macintosh. There we go. To the back, and we'll also go ahead and hook up our mouse. These computers are rather useless with only the keyboard. And go ahead and hook up our mouse. Okay. So let's see. So currently this is not connected to the drive. Just want to make sure that this cable is not causing any particular problems by itself. That's, you saw that, right? The drive just latched all by itself. Nothing connected, just by itself. Okay, we got the chime. And there it goes. Okay. So let's try connecting this to the actual drive. It's right in the back. And do some gymnastics here. So I'm actually holding down the eject mechanism with one finger. Put the disc in. Make sure, there we go. Okay, it seems very, so ejecting okay, but the See there, it dropped the head right onto the metal, which is not great. There we go. Okay. All right. So let's see. This drive will boot over the original cable. Oh, it's booting. It's booting. Look at that. That is astonishing. All right. Look at that. It is booting, folks. This is a working floppy drive. Okay, so I think the next thing, so let's exercise this just a bit. You should be able to manually get it to engage by moving this little bar right here, just slightly inwards. You can see it catches this little stub here. Push that in, it goes down, eject, down, eject, down. Actually seems to be working rather well. I think I'll do a complete re-oil of this drive. However, let's see if we can get the eject mechanism reinstalled. Eject mechanism, here we go. All right, our repaired eject mechanism, new gear. So with the drive ejected, so this is the engaged and down position, we want it in the up position because we want to make sure that this little peg clears, because it's going to push on this plate down here. So with that, we can go ahead and get this back into position. It should just pop right in. Looks like to fit into place. Okay. Go ahead and screw that down. Right. So with that in place, it may not allow us to manually engage it. No, because it's being held open by the eject motor. However, well, I suppose the best thing to do would be to go ahead and reconnect it to our Macintosh board. I'll go ahead and plug our cable in. And let's make sure that it's not this eject motor that was causing the short. That's good news. Okay. Macintosh is coming on. So let's go ahead and pop in our boot disk. It's booting. We do know that if we shut down, it should attempt to eject the disk. Well, that's great. Look at that. It should eject the disk. Okay. If I hold R on the keyboard, it will boot from the Rominator. So here on the desktop, this doesn't come across very well, but we have the Raminator disk. And if I insert the disk into the drive, it should show up on the desktop. And there we go. That is our Macintosh floppy drive. Open that up and take a look. See the contents. And I believe you can eject the disk. Well, that's fantastic. This is a fully repaired floppy drive. A little bit of oiling, reassembly in the case, and I think we're all done. Okay, coming back, I have added some oil, fresh oil to the drive, exercised it a good bit. I don't think there's any reason to reapply this magnetic, this little metal, which actually I'm really not sure the purpose. Is this shield? I imagine it's to keep debris potentially out of the spring mechanism. But what I'd be most worried about is that it fell off again. So I think now that this drive is working, I think it's time to put it back together. So I think we'll put this all back together. We'll do a quick wipe down actually, so that we have all this apart. Let's clean this up slightly. That is much better. So let's go ahead and get this back into the case. It may not seem obvious how this goes in, but as you can see, there's mounting screws here along the bottom. And we know that the connector needs to line up there in the back. So I'll just slide this back into the cage. Be a little fiddly. There we go. And that aligns nicely. So let's go ahead and get those screws back. Start on this side. Just make sure the drive is pretty well aligned. The screws will help pull that into the exact position. And thankfully, there's only a few types of screws in this drive, especially for the chassis itself. Next we will add our cable, which actually, now that we have it out for a minute, it's a great opportunity. Let's go ahead and give that cable a little bit of a clean. There's a lot of ways to do this, but I find a little bit of IPA just on the outside of the cable will do this wonders. It's going to help get off any of that old sticky residue and clean up a lot of the scuffs and the gunk that would have originally been on this wire. So here you can see those scuffs come right off. And that is looking way better already. So I'll just keep going around. here, clean that up. That is looking a lot better. Oh yeah, that is so much better. Almost looks new. So we'll go ahead and reconnect our connector here. And screw down the strain relief, which is probably unnecessary because the case does most of the work for us. All right. I think it's time to get this back in the chassis. So same thing here. I think a little bit of IPA will go a long way. I don't want to get too much on this label here. I might separately clean that with some Windex. But on these feet, it should do a world of good. Wow. Wow. You can see that 1 foot that I cleaned right here. How much dirt these other ones have collected. This almost looks brand new over here on this side with just a little bit of cleaning. So let's go ahead and do the others. Wow, I am genuinely surprised with how well that those cleaned up with just a little bit of IPA. Clean up the case just a little bit here. So, really is unfortunate about this crack. You can see it a good bit better here. See, the plastic is coming apart, so I may want to use some epoxy at a later date to get that looking a little bit better. But we will set that aside. Here's our other plate. Yeah, cracks in both halves of the plastic. So I guess that'll just add a little bit to the heritage of the drive. But I believe now we can go ahead and get this back in. There we go. Okay, those hooks, you can feel them have caught in the front. And now we'll go ahead and put these screws back in. Non-magnetic screwdrivers, folks. Just a little bit better view. Go ahead and get these screws back in. That is tricky, Apple. It's not like this. It's like this. Just slightly more in than you would think. And there it goes. That wasn't so bad. Go ahead and get these 4 screws back in. that's it. That is a repaired floppy drive. So now I think we can remove this sticker because it is no longer dead and does not blow our power supply. So that is a successful repair.